Show 5, catch that. Victor 73 miles, approaching glide path.
So what you've just seen is the MultiStation. Okay, it's the Leica Nova MS50, and it's all those things and more. The family of Nova has 3 different instruments in it. It has the MS50, which is the MultiStation, which we'll be talking about most of the morning. There's a new instrument, a half-second TS50. I don't know if any of you are familiar with our TS30, but the TS50 replaces the TS30. And then there's a TM50, which replaces the TM30. These instruments have been running in mines now 4 years straight, 24 hours a day. They only need service every 2 years with a 24-hour operation of mine. You guys all know mining out here. It's a pretty rough environment. So they're pretty hardy instruments. Customers basically started asking to merge together different technologies. How can we get to the GPS data and the TPS data, the total station data, to all begin to come into one? How do we begin to merge all this stuff together? Well, that's MergeTEC. Leica came up, they've just called it MergeTEC. And we'll go over MergeTEC and what that means. But it's basically the ability to combine GPS data, total station data, scan data, all into one. A couple of years ago, they introduced the TS15i. I don't know how many of you guys may see those or run those, but it was basically an instrument that had a camera built right into it. And one of the things they showed in that quick little video we were watching was the top-mounted camera on top of the total station. So same concept, except built right into it. So building on that technology, building on the precision total station stuff, the half-second, 1-second stuff that only Leica can do. You know, when you look at monitoring worldwide, it's always a Leica instrument in there because they're the only ones reliable enough to run consistently. So it brings that precision in. The Viva philosophy also was kind of bringing in all the different technologies together to include GPS. You can put the GPS on the pole and run it. You can put the GPS on top of the MS50 and run it. It's all, again, bringing it all together. And then the scanning. Leica, through an acquisition of Syra, had the first scanner. And so now we're bringing that into MultiTEC. So that's what MultiTEC is. It's all these different technologies brought into the one MS50. So 10 plus years ago when the Syra was out, this is the kind of stuff you had to do to get a scan-in and a total station working together. If I was to scan a room like this with more than one setup, meaning I'm going to scan from here, and I'm going to move my scanner over there, and they have to together, I would have to lay out control points all around the room so that my scanner picks up the control points from here, picks up the control points from there. You would go through back computing the positions of every one of them, resecting them in, right, registering all the files, and it took this whole mess of stuff, and we're not even on a real-world system here. This is just some localized system. You know, if you want to pull it on a real-world system, you got to have a GPS in the whole mix too. So that's what we've eliminated, and the little tiny thing on the tripod out there is what we have now. So what is the MS50 really? First and foremost, it's a robot. It's a regular robot that'll go out there every day and put in wood faster than any other robot out there. It's a regular robot that'll go out there and topo faster than any other topo. It's incredibly fast. And how do they do that? Well, they have these new motors called these piezoelectric motors. And the way that works is when there's certain materials that when you apply electric charge to them, they vibrate or move. So they developed a crystal that had a very specific movement to it. It moves every time there's a charge applied to it. There's a little nipple on there that, if you think about like as a kid playing on a merry-go-round, right? And you'd stand there and kind of kick the merry-go-round with your arm, one after the other. Well, it's exactly the same thing inside. You have a ceramic disc and a ceramic disc, and they're sitting there. There's a positive contact with them. There's nothing floating. There's no gears. There's no bearings. There's a positive ceramic to ceramic, and then one disc is being turned by this piezo motor. So every time they apply charge to it, this little nose kicks and it moves it about a nanometer. Okay? And by applying a lot of charge to it, they can get it moving pretty darn quick. In fact, they can go 180 degrees per second. So what makes this nice is that it's the direct drive. Now, direct drive means that it doesn't float on anything. It sits there, like I said, solid, one on top of the other. So what does that mean to us? It means that we get incredible battery life out of these things. Some of the instruments that float, they constantly have to float the instrument. They constantly have to apply a charge to it, kind of like a monorail. Well, we don't want a monorail, we want a survey instrument. So by having these two touch like that, it's at rest. And because we can apply a charge and tell it exactly how far I want to turn, let's say I'm doing a staking job and I want to turn exactly 45 degrees. There's no estimate to it. It doesn't, on the floating instruments, it kind of goes 45 degrees, and then it has to do some checks and balances inside to continue to make adjustments the whole time. This doesn't. It just turns 45 and it's done, and it sits there and rests until you tell it to do something again. So that's part of the technology. There's a 5 megapixel camera on top. So again, part of MergeTEC is having this camera technology. It's the same 5 megapixel camera that we had on the TS15i. It's a nice way to integrate in that technology. Leica's been integrating this technology into us over the years. Really, this is what it's all been about. This is what all these little mini technologies have been about. So the 5 megapixel camera on top, we have a new camera inside. So right down inside the optics, you got a 30 power scope and a 30 power camera. And we're going to take a look at that outside in a bit and show you just exactly what you could do with that. We have an electronic focus now. So one of the things is you can run this from the robot. You can run robotically, and anything you would, if you want to see exactly what the instrument's looking at, look down at the screen. And then you can see exactly what's happening, just as if you're looking through the scope. So because of that, I need to focus it. So I can focus it individually on one point, or I can just say autofocus. And no matter where I go, the center of it is going to consistently focus against it. And this is just some showing a little bit of what we'll see outside for those who decide to go outside. So you have the 5 megapixel camera, and then the same thing looking at it through the 31. And then even zoomed in a little more. So we'll take a look at those outside. We needed a new EDM. So we have a 2,000 meter EDM now. Okay, so what does that mean, 2,000 meter EDM? I don't know, I can't even see 2,000 meters, so what, even through a scope, I don't know what I'm looking at. So what good is a 2,000 meter EDM? Think of it more as horsepower. Okay? More than the ability to look out to 2,000 meters, how about the ability to look out to 1,000 feet and shoot reflectively anything I want to shoot at 1,000 feet? I don't. If anybody's used reflectiveness before, when you get into things like raw steel, it can be very difficult to shoot with any EDM. This will shoot raw steel out to 1,000 feet, and I definitely shoot things at 1,000 feet. So think of it as a horsepower more than anything. The last generation one was a 1,000 meter EDM. Just kind of as an example, from about 5-foot tripod, I could look out about 200 feet with a 1,000 meter EDM and collect the black asphalt. Wow. With this one, I'll be out 300, maybe 350. So you're talking about an extreme incline, you're talking about an extreme color, okay? So that's the difference. Think of it as a, I'll never shoot that 2,000 meters. No. So think of it more as a horsepower. And where does the 2,000 meter come from? That's coming from the industry standard. The industry standard is against a Kodak white lens. Kodak white paper. The old industry standard was a Kodak gray. The new one's a Kodak white. Leica doesn't pick it. Leica just conforms to the standard. So if you have a perpendicular piece of Kodak paper 2,000 meters away, you'll nail it every time. It's extremely fast. We're gonna set up a prism outside and snap the prism. Maybe you guys in your robots now use a tracking mode, right? And it's constantly shooting out distances, and you hit the button. Well, anytime you use a tracking mode, you lose some of the accuracy because it's not going through all of the control criteria that it needs to measure the point. It's just merely picking up whatever's coming back at it next. That's the way tracking works for all the technologies. I don't care what brand it is. This one, it's so fast. It's shooting 1,000,000 points a second, and it's sampling 1,000 of those points. So we'll get to see that in just a minute too, but it's extremely fast. And when we go out there, you watch how fast I hit that button and take real full-on measurements, how quickly it returns that. As fast as any tracker ever did. It's extremely accurate. It's a millimeter plus 1.5 part per million. So again, extremely tight, extremely accurate EDM. Okay, so the waveform EDM. What is the waveform digitized? The way this thing works is it's constantly sending out data. At least it seems constant. There's no such thing as a constant EDM. But it sends out data at 1,000,000 hertz, okay? So 1,000,000 times a second, this thing is sending out data. Now that data is sampled, and they sample the data about, I think it's 1,000 times every second. They take 1,000 pieces of data out of that sample to come up with the good data. And this is an example of 1,000th of a second, what it's getting out of that. And then this would be, I think, the full second, where it's taken all that data, put it together to come up with an EDM range. Now there's a bunch of mumbo-jumbo I'm reading off here, okay? And I don't really understand what it says, and I don't think I can explain it. It's the technical way this works. So my kindergarten version is it shoots out 1,000,000 times a second, it samples that data 1,000 times a second, and gives us back readings. So it's extremely fast. Any questions so far? Any double E's in the room? Good. Now that 1,000 points a second is up to 300 meters. So it does have a limit in the range. Because it's constantly measuring, you're not actually telling it to measure. You're just telling it to take a sample at a certain particular time. So it's constantly measuring. And up to 300 meters, it'll give you that constant reading back on just about any surface that you want. Okay, some of the dark blacks we may still have some problem with, but it's almost virtually eliminated out to 300 meters. It'll shoot just about anything. And there's a ½ millimeter of range noise at 50 meters. So at 50 meters, it's able to whittle out down to about a ½ millimeter. It's a pretty darn good EDM. So the workflow is pretty important because you gather all this data together, and if you can't make heads or tails of it, what difference does it make? So talking about the workflow, does anybody run the Viva stuff now? It's extremely simple. It takes me, when I sell this product, it takes me, an hour to teach somebody how to go out and do a topo, or a ½ hour to teach them how to stake. So the data flow is simple. It's part of the Viva measuring technology, and we'll be looking at that a little bit on the hardware as well. You can define scanning areas using the cameras. So again, integrating all this in. Here's the significant part. It'll scan 1,000 points a second. Okay, so that's a lot of points. What am I going to do with all that? Well, the lucky thing here, the nice thing, is it doesn't label the points 1 to 1,000 every second, so that you end up with point number 10,480,000. It doesn't do that. It takes all this data and keeps it in the background inside of a scan cloud, a scan data. It's separate. So when I shoot point number 1 and 2 and 3, I'm looking at point number 1 and 2 and 3. I'm not looking at however many points it took during the scan. We're the only ones who do that. There are some other ones out there that claim to have scanning EDMs. We don't think they're scanning instruments because they shoot about 5 to 10 points a second. 1,000 points a second, that's a real scanning range. And it's important because it's kept in a separate database. If it was kept in the same one, you'd be scrolling forever to find your points. Once we get the data, how do we view it? So you can view the 3D point cloud right on the instrument, okay, on the robot. And we'll take a look at that. We'll pull it in and spin it around a little bit. Intensity view is what most people look at, okay? And I don't know if I go one past here. Yeah. And they showed kind of this image inside the video that we watched. It's the same thing. We'll scan some things out there and we'll spin them and rotate them. You can look at them in different angles. The cool thing, you can scan right away, a single scan from a first setup. You can scan from another setup. So let's say I resect my gun in using my GPS, right? I got my GPS on the pole, I take 3 or 4 shots. I'm now in state plane, I do a scan on one side of the building. I pick up the gun, and throw it on the other side of the building, and I resect that in, take 2 or 3 minutes to resect that in. I can scan it from another one, and I can have all that stuff combined. And this is the cool part. You can see it all in one big scan. It's automatically registered on the spot at that moment. There's nothing to do beyond that. When that point cloud comes out, it's done, it's ready. Now if I want to bring it into a software and adjust it, meaning the total station point, I run a traverse adjustment, or I put new control data on it, or I don't know, the knucklehead read the height of the instrument wrong and I got to put it in right. Well, we can make those changes, but the scan data is ready to go. There's nothing else to do to it. You can zoom in, check all the little details, things like that. So it runs on SmartWorks Viva, like I said. It's the same software that we run on all our other total stations. It's an IP65 rating. So an IP65 is the highest instrument rating out of any instrument anywhere. And the 6 stands for dust. It means in any environment you can use it in dust. There is no higher rating than a 6 for the dust side. So any kind of a mine, anything you can throw at it here in Nevada, and I know you guys got the dust, it can handle it, no problems at all, continuing on that 2-year service cycle. So you're not going to have a problem with dust. The 5 is the rain side. You can use it in a downpour. 5 is as high as any instrument will go. If it was a 6, we'd be dunking it in the water. Okay, so actually a 7 is a dunk in the water. 6 is a splash quick submersion. So they have rules behind it. So a 5, any rainstorm you can come up with, you can run it out there if you want to do that. I know you guys get some good rates here. Temperature range -20 to +50. That's basically
Cold and hot.
-4 to 127, something like that. It's 0 to 120, which is a pretty good range for what it'll do. Compatible with all our Viva controllers. So if you already run, you're running your GS14, fully compatible with it. There's nothing you need to do to it, except make sure it has current firmware. But that's it. Nothing else you need to do. It's ready to go right now, ready to scan. So, different ways that you can communicate with it. Again, everything we've done before, we've added a couple to it. The radio technology is actually a long-range Bluetooth radio. Again, it goes out about 3,000 feet. It's incredible. It's fast as lightning. I mean, I'm sending these 5-megapixel photos over the airwaves robotically within seconds. It's screaming fast. And data transfer, the way that a USB stick is the way we transfer the data most often. Any USB stick. Stick it in the gun, transfer the data over, walk it into the office. You don't need anything complex, any special readers. If your computer doesn't have a USB on it, it's time to buy a new computer. So we got the 5-megapixel camera. We got the autofocus. We got the on-axis camera, which is the one that's inside the scope. These are all new things. We have the piezo drives, extremely fast, extremely precise, we have the waveform, digitized, EDM, all the different communications that we have, and an IP65 rating. So it's a pretty unique instrument in the industry. There's absolutely nothing like it. The interesting thing is there's not going to be anything like it for a while. One of the guys who works at Leica hired during the construction of this, at the end phase of this, was working at one of our competitors, the next closest one to having anything like this, and they're a year, perhaps 2 years away from being able to release anything like this. That's MergeTEC. That's all we got until we go outside and take a look.